Notice the question here. What we need to find is area of this region. Of course, they have given radius r. So the area will be in terms of r or some alphabet for that matter, not definitely a number. So how to find this? In areas related to circles, first what you need to do is you need to generalize before substituting any value. You need to get the formula, and then if required you need to find the unknown and substitute it for the values. So what generalization we can make here? You can write shaded region area is equal to area of segment of circle of radius r. It is already given that the radius is r. So let's say this is the center. Let me call this as O. And if I connect, this is the radius. Similarly, let us connect from the other end. So this is our radius r. Now this area of segment is equal to area of sector OAB minus area of triangle OAB. Now let us say this is theta. Thus area of sector OAB is equal to theta by 360 into pi r square minus area of triangle OAB. How we can find this? We can find by drawing a perpendicular from O to the chord which bisects AB. So this is nothing but 2 times of area of triangle O. Let's say this is x. So OXA, which again is equal to theta by 360 into pi r square minus 2 into half BH, it is half into AX into OX. Now we need to find the value of theta to get the final answer. How do you do that? The only clue what we have is this is a equilateral triangle. So obviously this angle will be 60 degree. So if this angle is 60 degree, then this particular angle or theta, it will be equal to 120 degree. This is from a theorem that you studied in class 9, that angle subtended by a chord at the center is twice the angle subtended by the ends of the chord at any other point on the opposite side of a segment. So by that theorem, if this is 60 degree, this is 120 degree. So applying this, we'll get 120 by 360 into pi r square minus AX into OX. Now let us find AX. Consider triangle OAX. Here, this angle is theta by 2 and this angle is theta by 2. Since OX bisects AB and also the angle theta. We know theta equal to 120 degree, so therefore theta by 2 equal to 60 degree. So using trigonometry, we can find AX and OX. So we can write sine 60 equal to AX by OA, or root 3 by 2 equal to AX by R. Similarly, OX can be found using cos theta. So cos 60 equal to OX by OA, which is 1 by 2 equal to OX by R. So substituting these two values, you can write pi r square by 3 minus root 3 by 2 r into 1 by 2 r. So the final answer you will get in terms of r on simplifying this. So what you need to understand here is generalization. Do not substitute the value of pi till you reach the final point, wherein beyond this point you may have to substitute and find the final answer. Because if you start substituting the value of pi here itself, then it may lead to some calculation errors, because there is a possibility of you making some calculation mistakes. To avoid that, it is suggested to carry on pi without any substitution till the end of the problem. Now let us look at the next one. Now what we need to find is a simple difference between the two segments formed by a chord in a circle. Let's say this is the chord, AB, which subtends an angle 90 degree at the center, that is theta equal to 90 degree. So what we need to find is the difference between the area of the segments. What are the segments involved here? This is segment 1 and this is segment 2, which includes this triangle also. This is segment 1 and this is segment 2. So we need to find the area or difference in areas of two segments. This segment 2 minus segment 1. So this is the generalization what we can do first, and now we will proceed further to find the segments. Let us first find segment 1. So segment 1 is nothing but area of sector OAB minus area of triangle OAB. Since 90 degree is the subtended angle, we can get 90 by 360 into pi r square minus half into OA into OB. Because since this is a right triangle, one of the sides that is not hypotenuse can be taken as base. Let's say in this case OA is the base and other side as height. So half into OA into OB. But OA and OB are nothing but the radius. So therefore we can write pi r square by 4 minus r square by 2. So this for segment 1. And for segment 2, segment 2 is nothing but the major segment of the circle. It is nothing but area of the total circle minus area of segment 1. So therefore segment 2 minus segment 1 is equal to area of circle minus segment 1 area this is area of segment 2 minus segment 1. So substitute the value of segment 1 here and solve this. So how does this look like? Here we have an equilateral triangle OAB. So let's say this is the equilateral triangle. So sorry that I am poor in drawing. Hope you would understand this, accept this as an equilateral triangle. So this is OAB with vertex O, where a circular arc of radius 6 centimeter has been drawn with vertex O as center. So I am drawing a circular arc from here, and this is 6 centimeter. However, the side of this equilateral triangle is 12 centimeter, which is given here. Now what we need to know or need to understand, now what we need to find is this shaded region. So the question must be, there should be a small change in question, that is find the area of the region where a circular arc has been drawn with vertex O of an equilateral triangle OAB of side 12 centimeter as center. Okay. Now how to find this? Let us first go for generalization. Now area of shaded region is equal to area of this circle. So I am assuming this to be a complete circle. So area of circle plus area of this equilateral triangle minus area of this particular sector. Why? Because there is an overlap of this sector from equilateral triangle point of view and also from the circle point of view. So there are two sectors that lies here. So we are subtracting one of them. So the angle of this sector is equal to 60 degree because this is an equilateral triangle. So this will be pi r square plus root 3 by 4 AB square minus 60 by 360 into pi r square. Solve this to get the actual answer. The actual answer is 156.5 centimeter square. Now what you need to understand from this question is, when two such figures are given which overlaps, take care to note if any of their parts it overlaps. If it overlaps, then subtract any one part or both the parts depending upon the question which is being asked. So now what we need to find is the area of white region, black region, blue region, red and gold region. How to find this? First let us go for generalization. That will help you immensely in solving this. And you may even derive a new formula to solve this easily. Now let us first consider only the red and gold region parts. This is the red region and this is the gold region. So it is already given that the diameter of the region representing gold is 21 centimeter and other band is 10.5 centimeter wide. So let me call this as radius of gold, and let this be W, width of red region. So width will be on both sides, so this is W again, and this is again R. Now you can notice that R equal to 21 by 2, which is equal to 10.5 centimeter, and W is also equal to 10.5 centimeter. So therefore, R is equal to W. Now radius of red region, this is equal to R plus W, which is equal to 2R. Now area of red region is equal to area of red circle, the complete red circle, minus area of the complete gold circle. So that's equal to pi R of red the whole square minus pi R square. So which on solving will yield 3 pi R square. So area of red region is 3 pi R square. Similarly, when we consider the blue circle, we need to add another W to find the radius of the blue circle. So now radius of blue circle is equal to radius of red circle plus W, which is again equal to R. So that gives us 3R. So what you are trying to do is, we are eliminating many of the variables involved. Here the area of red circle is a variable, radius of red circle is a variable, so as with blue circle, and also with black, and also with white. So we are reducing all these unknowns to one single unknown or minimum number of unknowns, so that it becomes easier for us to solve the problem. So now radius of blue circle is 3R. Now area of blue region, this is equal to area of blue circle minus area of a complete red circle. So that on substituting the relevant values, we get 5 pi R square. So if you proceed further in the same fashion, I can see a pattern that area of red circle is 3 pi R square and area of blue circle is 5 pi R square, and definitely in calculation you will find that area of black circle is 7 pi R square. That is, every area it differs by 2 pi R square terms. And similarly, area of white circle is 9 pi R square. So now it becomes much easier for you, because what you need to substitute is just the value of R here, R here, R here, and R here to get the relevant values, like area of red region, area of black region, white region, and of course the blue region. So substitute the values and get the final answer. So what you could understand from this question is, try to simplify the question as much as possible with generalization rather than substituting the value every now and then. So value substitution at the beginning may lead to a lot of calculation errors. So avoid that.